All right, let's talk about AI's dirty little secret. Today, we're going to pull back the curtain on something that can make or break any AI project, something that really decides if it's going to be a brilliant success or, well, a total failure. Let's get right into it.
You've seen this happen, right? Some company pours millions of dollars into a new AI, and it's supposed to be this incredible genius, but then it can't tell a cat from a dog or it completely botches a simple command. It's frustrating, it can be pretty embarrassing, and it happens all the time. So, what is really going on here?
Okay, get ready for this number. 30 to 50%. That's the amount of pure noise, we're talking errors, duplicates, totally irrelevant stuff, just junk, that's hiding in the average data set used to train AI. Just imagine trying to learn a new language, but half the words in your textbook are just complete gibberish. That's pretty much what we're asking our AIs to do. And that, right there, is the heart of the whole problem. It's usually not a bad algorithm. It's not that the AI model itself is weak. 9 times out of 10, the real reason for these failures is the low-quality fuel we're pumping into a high-performance engine. You've probably heard this before. It's the oldest rule in the book when it comes to computing. But you know what? It has never been more true than it is today with AI. If you feed an AI system garbage data, you are absolutely going to get garbage results. It really is that simple. So this really forces us to change how we think about building AI. The old way was just brute force, shovel massive mountains of data at a model and just hope for the best. The new way, the smart way, is to actually engineer the outcome you want by carefully engineering the data you use in the first place. So how do we do that? Well, the solution is a process called data quality grading. I want you to think of it like panning for gold. You're taking all this digital chaos, all this dirt and rock, and you're systematically washing it away to find those little nuggets of pure gold inside. So what does data quality grading actually mean? Well, it's a formal way to systematically look at your data and sort it into different levels of quality. And listen, this isn't just about cleaning the data. It's about classifying it, understanding its real value, and then creating these really strategic, high-quality, smaller data sets from that giant, messy pile you started with. And this table right here, this is basically our blueprint. We create this hierarchy. At the bottom, you have grade C. That's our raw, barely filtered data. Then you move up to grade B, which is a pretty decent usable set. Grade A is our high-quality stuff, the main data we'll use for training. And then at the very top, you have grade S, the golden data set. This stuff is near perfect. This map is the key to the whole process. Okay, so let's make this real. Let's walk through how this whole data refinery process actually works. We're going to use an example, taking a huge, messy pile of 100,000 photos and refining it all the way down to just 8,000 perfect shots. Here's our roadmap. It's a 4-step journey. We start with that big, unfiltered, raw dataset. Then we do a first filter using clustering to create what we call the core dataset. After that, we use a bunch of AIs to get a consensus and create the core of core set. And then, finally, we bring in humans to verify everything and create that golden dataset. All right, step 1. Easy enough. We start with our huge pool of 100,000 raw images. This is our grade C material. And remember, it's full of that 30 to 50% noise we talked about. Blurry photos, pictures of the wrong thing, duplicates, you name it, it's in there. Now for the first big cut. We use automated tools like clustering, which can group similar images together and automatically kick out the obvious junk and outliers. This first pass makes a huge difference. It shrinks our dataset from 100,000 down to a much more manageable 40,000 images. And this becomes our grade B, or core dataset. Okay, step 3 is where things get really clever. We take that grade B dataset and we make it run a gauntlet. We have several different AI models look at every single image, and the only ones that make it through are the ones that all of the AIs agree on. It's like a quality check by a panel of AI judges. This process cuts out a lot of the subtle mistakes, and it cuts our data set in half again, down to 20,000 really high-quality images. This is our grade A dataset. And now, for the final and maybe most important step, we bring in the humans. Real-life experts go through those 20,000 grade A images, and they handpick only the absolute best of the best, the images that perfectly represent the ground truth. This gives us our 8,000 image grade S golden dataset. It might be small, but it is practically perfect. So we did all that work. We've got this perfect golden dataset. Now what? You might be surprised to hear that the real genius of this whole system isn't just creating that grade S data. It's about how you strategically use all the different grades you've just made. This brings up a really important question, right? Do you just throw everything else in the trash and train your AI on only those 8,000 perfect golden images? I mean, it seems like the logical thing to do, but the answer isn't what you'd think.
And the answer is a big, fat no. See, if you only train an AI on perfect data, it can become fragile. It won't know how to handle the messy, imperfect data it's going to see in the real world. So, the secret is to feed your AI a balanced diet by strategically blending all the different grades of data together.
Think of it like a recipe. First, you build a strong foundation by training the model on the best stuff, the grade S and A data. This teaches it the core patterns correctly. Then, you reinforce that learning by mixing in the larger grade B dataset. That adds volume and variety. And finally, you strategically sprinkle in some of that messy grade C data. That teaches the model how to be flexible and handle the kind of chaotic data we'll actually encounter out there. So let's step back. What's the big payoff here? Why does this whole systematic approach to data quality pretty much change the entire game for AI? Well, just look at this chart. This is a real eye-opener. Studies show that in successful AI projects, a staggering 80% of the work, 80%, is spent on getting the data right, preparing it, managing it, making sure it's high quality. Only 20% is spent on what we think of as the fun part, building and tweaking the actual model. The real work, the stuff that truly matters, happens with the data. And the results? They really speak for themselves. Teams that put a serious data grading system like this into practice see their model's accuracy jump by 20 to 30%. I mean, that's not a small tweak. That is a massive improvement. That's often the difference between a cool science project and a product that actually works in the real world. So let's wrap this up. What this all means is that grading your data seriously boosts an AI's accuracy and makes it way more reliable. By being super careful about what the AI learns, you get rid of a lot of weird, unpredictable errors and biases. And maybe the coolest part is, you start to see that digital noise not as a problem to throw away, but as a strategic asset you can actually manage and use. This whole idea is the foundation of what people now call data-centric AI. And that leaves us with one final thought. For years, the big race in AI was all about who could write better code, who could build bigger and more complex models. But maybe, just maybe, the real key to unlocking that next generation of AI isn't in the code at all. Maybe it's in the care, the quality, and the craftsmanship of the data we choose to feed it.